Hello everyone and welcome to another part of the Galaga SDL tutorial videos, and in this video we're going to implement broad phase collision into our game. So far we have all our colliders as box colliders for the entities, but box-box collision could actually be pretty expensive once we have a lot of entities on the screen. So an easier or faster way to do this is to have a circle collider that surrounds all our colliders for a single entity, and if two broad phase colliders, which will be circle colliders in our case, overlap, we can do the narrow phase collision and check all the other colliders against each other for only these two entities. So for the most part, we're just going to be doing circle collision on all our entities, and then once two circles overlap, we do the box collision. So let's get started first by creating our circle collider. Let's go to our physics, filter, and add a new item. And in here we will have circle collider.h, and then if not defined, underscore circle collider underscore h, define underscore circle collider underscore h. Alright, so this class will inherit from our collider class as well, just like the box collider. So we can include collider.h here, then class circle collider public collider. Now, the first thing that we need is to declare our member variables, and the only member variable that we need for this class is just the radius of the collider. So private float mRadius. Then for the public section, we want the constructor and destructor. The circle collider. First, our constructor will take in the radius of the collider we're about to create. So float radius. But it will also take a boolean to tell it whether or not it's a broad phase collider or a normal collider. We're going to use that so that we can load a different texture so we can debug the broad phase colliders much better. We'll call this one broad phase, and this one will start off being false by default. This way we can just create our normal colliders by passing in a radius, and then if we want to create a broad phase collider, we can just set this one to true. Then circle collider destructor, and that will be it for our .h for now. So let's move on to our .cpp, add new item, circle collider, and in here we will include our circle collider.h, then move on to our constructor. So circle collider, we have our parameters here, and we need to call our base classes constructor, which will be the collider. So collider, and that will take a type, and our type will be circle. Then now the first thing that we need to do in our constructor is to assign our mRadius, and our mRadius is going to be equal to radius. And then we need to load our debug textures if we are debugging the colliders. So if debug colliders, we need to check if it's broad phase or not. So if broad phase, set debug texture to be a new texture, which will be called broad phase collider.png, and then else set the debug texture to be a new texture, which will be called circle collider.png. And that will be it for setting our textures. Next thing that we need to do is set the scale of the texture that we just passed in. So mdebug texture scale is going to be equal to vector2 underscore 1 multiplied by our radius, but our radius, we need to multiply our radius by 2 to get the diameter, so we know the width of our texture. So radius times 2, and we will divide by 100.0f. That way we have our actual size because my circle collider.png and broad face collider.png, they're both 100 by 100 textures, just like the box. Okay, so that will be it for our constructor for now. We need to implement our destructor, and that will be just an empty destructor. So circle collider, and this will be it for this class for now. Now to move on to our collider.h, we need to create two new functions. The first one will be a pure virtual function, so virtual vector2, and this one will be called get furthest point equals 0. And the reason why it's a pure virtual function is because the base collider class doesn't really know what a furthest point is. For example, our circle collider, the furthest point will be its radius. For the box collider, the furthest point will be the furthest index in the rectangle. So that will be a pure virtual function in the base class. And then we will also have a collider type function called getType. And all this would do is just return mtype, because we will need to figure out whether we actually need a broad face collider or not. If we have an object that only has a circle collider, we don't need a broad face collider for that, because it would just be redundant. They would both be the same radius, so there's no point in doing two circle collisions in a row with the same radius circle. And but if we have a box, on the other hand, we do want a broad face collider, and that's what we're going to use getType for. Now to move on to our collider.cpp, we need to implement this function. So in collider.cpp, underneath set debug texture, we can say that collider type, collider getType, not this one, getType, will just return mtype. And that will be it for our collider.h and collider.cpp. Now to move on to our circle collider.h, let's move back to that now and implement our getFurthestPoint function. So over here under the destructor, we can say vector2 getFurthestPoint override, and we can go to our CPP now and say that our vector2 circle collider getFurthestPoint. This one, we need to find out where the furthest point is of the collider from the furthest point of the collider from the entity, the center of the entity. So if I open up Paint here for a second, let's say that we have two circle colliders on the same object. So let's say we have one here, and the center of our object is, let's say, here, and then we have another circle collider there. The furthest point of our collider will be the distance from this point right here to the middle of our collider, and then we add the radius of the collider on top of it. So these two will be furthest points for each one of these colliders. So to do this, we need to return our vector2 underscore right multiplied by our mRadius plus our position game entity local dot magnitude. Okay, and to explain this a little bit further, so we have our vector2 underscore right, and we're using that so that our furthest point, we only have the magnitude on the x, so that we don't split it in between x and y and then figure out the magnitude later on. We can just use the x value and that's it. So our radius, we're getting the radius, so the distance from here to the center of our collider, and then our local position dot magnitude, so the distance from the object to the center of the collider itself. So we have this entire value. Now the box collider one is going to be a bit more complicated. So if we go to box collider.h and override the same function, so vector2 get furthest point, override. And then we go to our box_collider.cpp. Right above advert here, we can add our vector2 box_collider get furthest point. And for the box, on the other hand, let's say we have our player setup. So for our player, we have a box right here, a box right there, and a box right here. So the center of our player is right there. The furthest point needs to be, so let's say the middle of our collider is here and there. It needs to be the distance from the center of the player to the distance of the box. We add to it the distance of the vertex from the distance of the collider, from the center of the collider, and then we get the magnitude of that to get this distance right here. So what we're trying to figure out is how far is each vertex in this box from the center of the entity we're attached to. So for this, what we're going to do is to first get the local position of the collider relative to the player. So we can say vector2 local position is going to be equal to position game entity local, and that gives us our local position. Then we can say int furthest index is going to be equal to 0. So we're assuming that the first index is the furthest one to start off with. And then float distance is going to be equal to our local position plus our inverts at 0 position game entity local. So we're adding these two just like we did here. So we're getting from here to there and then from here to there. So I should probably make it a bit clearer than that. So from here to there and then from here to there, and then we just need to get the magnitude of that. So we can say get all this dot magnitude squared. And the reason why we're getting the magnitude squared right now is because we're just comparing values. We'll get the actual magnitude once we find out what the furthest vertex is. So now that we have all this here, we can go on and say float other distance is going to be equal to 0.0. Now for int I equals 1, I is less than max verts I plus plus, and then other distance is going to be equal to pretty much what we did here, but with vertex at I instead. So local position plus inverts at I position game entity local, and then we just want to get the dot magnitude squared of that. And then we can say if the other distance is more than our current distance, so if other distance is more than our distance, our furthest index is going to be equal to I, and our distance is going to be equal to the other distance. There we go. So, and that will be it for our loop. Now that we figured out what the furthest index is, we can return the actual furthest point, which will be, so return the local position plus inverts at the furthest index position game entity local. And that will be it for our get furthest point for a box. Now that we have everything set up, we can now move on to our physics entity.h and start implementing our broad phase collision for it. So in our physics entity.h, we have a vector of all our colliders here. So we need to add one more collider pointer. So collider pointer m broad phase collider. And that will be it for our .h. Now for our physics entity.cpp, we need to initialize it. So m broad phase collider is equal to a null pointer. And then in our destructor, we need to clear it if we assign it anything. So if m broad phase collider, we want to delete it and set it back to null. So equals a null pointer. There we go. Now whenever we add a new collider to our physics entity, we want to recalculate the broad phase collider. So in here we can say if our colliders dot size is more than 1, so if the collider dot size is more than 1, we want a broad phase collider regardless. Or our M colliders at 0 get type is equal to, or if the type is not equal to collider type circle. And what this is basically saying is that if our if our first collider that we added in is not a circle, then regardless whether our collider dot size is 1 or not, we need a broad phase collider. So now that we have this here, we can move on to creating that broad phase collider. So we want to know what the width of that collider is, so the radius of our circle. Float furthest, so furthest distance is going to be equal to M colliders at 0, get furthest point dot magnitude, then float dist is going to be equal to 0.0f, and then for int I equals 1, I is less than M colliders dot size, then I plus plus. Our distance is going to be equal to basically what we did here, but with I instead. So M colliders at I, get furthest point dot magnitude. Then if our distance is more than the furthest distance, then we want to replace the furthest distance with our distance. So furthest distance is going to be equal to distance. Now that we have this, right outside the loop, we can create our broad phase collider. So first we need to delete the old one in case we had one to begin with. And then our broad phase collider is going to be equal to a new circle collider. Its radius will be our furthest distance, and broad phase will be equal to true. Now it's complaining because we haven't added circle collider.h to our CPP, so include circle collider.h. There we go. And then we need to say that our broad phase collider parent is going to be this, and the broad phase collider position is going to be vector2 underscore 0, just to center it on our object. And that will be it for adding our broad phase collider. Now in our render, we can say if M broad phase collider, just so that we can debug it, M broad phase collider render. So now that we have this, I have here the broad phase collider assets. So this is what it looks like. I have the broad phase collider, collider.png, which is blue, and then a circle collider.png, which is red. They're both 100 by 100 and circles. So these are what we are loading right here. Now that we have everything set up, I guess we can go ahead and run it and see how it goes. There we go. At least it ran. And then let's see. And there we go. As you can see, the player has 3 different colliders, but it picks the furthest point from the player center. And as you can see, the entire collider is has a circle around it. So we're not missing any collisions. If we enter the circle, we can do the box collisions inside. If we don't enter the circle, we can just ignore the collision altogether. And there we go. It's there for all the enemies as well, so we can do the same for the enemies, and it should be there for the bullets too. There we go. So it's there for the bullets. And yeah, that seems to be working. next video we'll probably start doing our collisions on the broad phase collider directly, so that if two broad phase colliders collide, we can set a collision to true, and then after that we can do our box collisions to get more accurate with our collisions. But that will be for another video, and this will be it for this video. I really hope that this video helped. If you have any questions, suggestions, or feedback, please leave them below. Otherwise, thank you very much for watching, and I will see you in the next video.